Welcome to our first flip lesson on equivalent ratios. This is a 2-day topic, and we are going to talk about ratios, proportions, and conversions. So let's begin by refreshing our memories. A ratio is a relationship in which for every x units of one quantity, there are y units of another quantity. The quantities x and y are the terms of the ratio. You can use ratios to make comparisons. The ratio of the number of circles, and you can see we have 2 circles, to the number of squares, and there's 1 square, can be written in 3 ways. The first way is to use the word 2 to 1. The second way is to use a colon, 2 to 1. And the third way is to use a fraction. So let's move on to an example. For this first example, they want us to write the ratio 3 ways. So let's look at what we're looking for. We're looking for the number of solid colored balls to the number of striped balls. So the first thing I'm going to do is I'm going to count these solid balls. And I count 1, 2, 3, 4. I count 4 solid balls. And the number of striped balls, 1, 2, 3, 4, 5. And so now I can answer the question. The number of solid to the number of striped is 4 to 5, and I can write it 3 ways. Next, they're asking for the number of even to the number of odd. Try this one on your own, please. And you can see my answers are 6 to 3, 6 to 3, and again, 6 to 3. Equivalent ratios are ratios that express the same relationship. You can find equivalent ratios by multiplying or dividing each term of the ratio by the same non-zero number. So if we look here, we have 2 circles to 6 squares. If I double this, double the numerator, double the denominator, both the terms, and I multiply by 2, I've taken 2 and I've made it 2 circles and made 4 circles. And I've taken 6 squares and I've made them into 12 squares. The same is true with using division. In this first example I multiplied, in the second one I'm going to use division. I took the first term of 2 and divided it by 2 to get 1, and then I took 6 and divided it by 2 to get 3. So the ratio is 1/3, 2 6, and 4 12ths are equivalent. Now let's look at these ratios. 4 to 5, 6 to 3, and 7/3. I want you to answer these questions, and then we will come back and work on them together. So which ratios can be written with greater terms? All of them. Each of the pieces can be multiplied by a non-zero number. Can any of them be written with lesser terms? The 6 to 3 can, because I can divide both 6 and 3 by 3, and it would simplify to 2 to 1. So let's look at this example here. You're given the ratio 12/15. Find an equivalent ratio with greater terms and one with lesser terms. So try this on your own, please. So for my first ratio with greater terms, I chose to multiply both pieces by 2, and I ended up with 24/30. You could have multiplied by 3 or 4 or any number. To write 12/15 with lesser terms, I divided both terms by 3, and I ended up with 4/5. Let's move on to proportions. A proportion is an equation that shows that 2 ratios are equivalent. For example, 2/3 is equal to 4/6, and x over 5 equals 16 over 20. In the second proportion, we do not know what x is yet. If we look at the 2/3 to 4/6, we can easily see that if I multiplied the top term, the 2, by 2, I would get 4. And if I multiplied 3 by 2, I would get 6. So let's try solving this proportion. The first step is to cross multiply. And the second step is to solve the equation using division. And I'm going to let you in on a hint now. I abbreviate the word equation EQN. I've found that we need to start using shortcuts when we write words so that we can save ourselves a little bit of time. If you're not going to remember EQN as equation, then write it out. Okay, so my first step is to cross multiply. So I'm going to multiply 20 and x, and when I do that, I get 20x. And then I'm going to multiply 5 times 16. And when I do that, I get 80. Now I'm going to use division, and the 20 and the x are held together by multiplication, which is why I'm going to divide both sides by 20. What I do to one side, I do to the other. And I get x to be 4. And if I want to go back and check if I put x in here as 4, 4 times 4 would give me 16, and 5 times 4 gives me 20. So those are equivalent, and 4 is correct. What I would like you to do now is solve the following proportions on your own, and then check with your partner. At this point, how did you do? I've got 2, 2.4, and 6. Notice I showed all of my work. And I needed a calculator for this one. All right, so let's move on to some word problems now. So here we want to set up a proportion and we want to solve it. If 4 bars of soap cost $1.50, how much would 10 bars cost? I like to, when I first get back into the practice of using these, I'm talking about bars of soap versus their cost. So I put a little note off to the side. Bars over soap, over cost, I'm sorry. So I have 4 bars, and they cost $1.50. How much would 10 bars cost? So the x is going to go where the number of bars is. And, nope, I'm sorry about that. Again, my bad. 10 bars, x is going to be where they cost. You can tell we're getting back into it from summer. So when I cross multiply, I get 4x equals 15. Now I divide both sides by 4. And I'm going to move up to here. And I get x to equal 375. So 10 bars would cost $3.75. Try the next two on your own, and then check your answers with your partner, please. So for B, I got 3 gallons, and for C, I got 1,440 feet squared. Notice I've gone and labeled each of my answers. I've put a box around them to help me point out where it is when I'm going to check it. But most important, I wrote off on the side my gallons to miles and my cans to feet squared, just to help me out. You also want to ask at the end, does your answer make sense? Okay, 3 gallons sounds reasonable for traveling 96 miles, okay? If I'm using 5 to travel 160, I'm obviously going to have to use less than 5 when I'm traveling 96 miles. The same with the paint question. If 2 gallons covers 900 square feet, 3.2 gallons is going to obviously have to cover more than 900 feet. So let's move on and let's look at this chart. You volunteer at an animal shelter and need to order supplies. You know that the ratio of kitten supplies to adult cat supplies for each category is equivalent. So we're going to complete the table. We need to figure out if the supplies are equivalent for the kittens to the adults, okay? How am I getting from each spot? So I want you to look at this chart for a minute and I want you to think about it. And see if you can come up with a way to complete the table. When I went to solve this, I know that my kittens to my cats, or I'm sorry, my kittens to my adult cats are in proportion. So I can make this an X for now. I'm going to put it up in the corner here. Okay? So if we look at food, the kittens to the adult cats, in comparison to the treats, 42 is to 56. When I solve that proportion, I end up getting X to be 6. So I can put a 6 in here. The same holds true when I look at the treats to the food in cans. I'm going to put a little Y here so I remember. So 42 to 56 equals 126 to Y. And when I do my math on that, I get Y to equal 168. Okay, so let's move into conversions. This is a major concept. When we have conversions, you can often write measurements in more than one way. For example, 1 hour is 60 minutes, or 60 minutes equals 1 hour. You can express the relationship between the two equivalent measurements as a rate. The rate equals 1 and is called a conversion factor. These conversion factors are equivalent because they describe the same relationship, 60 minutes to 1 hour or 1 hour to 60 minutes. Okay? Be careful. These are conversion factors and they have units, so we will have to write the units in 60 minutes, 1 hour and 60 minutes. And writing the words in the units is going to help us when we visually when we have to work on simplifying these. So let's look at the next slide. Write a conversion factor 2 ways to compare each of the following. So I'm looking at inches and I'm looking at feet. I have 12 inches in 1 foot, or I have 1 foot to 12 inches. Now, let's look at the next one, ounces and pounds. To refresh your memory, there are 16 ounces. OZ is the units, the way we would write that, to 1 pound. Pounds use LBS, and I'm using cursive when I do that, so it doesn't look like I have a 1 here. Or, I can do 1 pound to 16 ounces. Try the last one for me, and then we'll come back. I get 7 days to 1 week, or 1 week to 7 days. Okay, so this is the introduction to conversions. Now we're going to actually do a little bit of converting. So we have this question here. A summer camp has a milk dispenser that holds 1,536 fluid ounces. How many cups of milk are in the dispenser? So we're looking at fluid ounces and cups. So to do this, we need to multiply by a conversion factor. Remember, anytime you multiply a fraction by a form of 1, it's still the same fraction, okay? Or it's still the same ratio in this case. We need to know that 1 cup equals 8 fluid ounces. Now, here's a big hint, and I always use this when I'm doing conversions, even to this day, and I've been doing conversions for years. The conversion factor should have the original units, in this case the fluid ounces, in the denominator, and the new units in the numerator. So we have the new units are going to be in the numerator. Okay. So, I am starting with 1,536 fluid ounces. I'm going to multiply, big times sign, by my conversion factor. My new units, cups, needs to be in the numerator. So, let's look at my conversion. So here we go. We're going to put 1 cup in the numerator, which means the 8 fluid ounces goes in the denominator. Now, the nice thing about setting it up this way is that we can see the fluid ounces simplify. Because we have 1 in a numerator and 1 in a denominator. And we can do this when we have multiplication only. So now I need to do 1,536 times 1, and then 1 times 8, because I am multiplying 2 fractions. So I end up with 1536 cups divided by 8. When I do 1,536 divided by 8, I get 192 cups. So that milk dispenser holds 192 cups of milk. So let's look at the next example, and we will do this one together as well. Then I will give you some practice ones. The average dairy cow produces 1,500 gallons of milk per year. The milk bottling factory put milk into quart bottles. How many quarts of milk can it bottle each year from the average dairy cow? Let's make sure we show our work. Let's circle some important information. We're starting with 1,500 gallons. We're putting it into quarts. Okay, so that's my new unit, so it's going to be in the numerator when I go to do my conversion. Okay, so how many quarts? So we're starting with 1,500 gallons. We said the new has to go in the numerator. So we're going to multiply by 4 quarts to 1 gallon. And this is what we like. We like seeing the gallons disappear. They simplified. And we're left with just quarts. And that's what we wanted to end up with, was quarts. So 1,500 times 4 is 6,000. So we have 6,000 quarts. That is a lot of milk. Okay. So it can bottle 6,000 quarts of milk from 1 average dairy cow. On the next page, there are 3 examples. Please try these, and then come back, and we'll start back up, and I will have the solutions up for you. So the first one was pretty straightforward for 9A. 16 yards, there's 3 feet in 1 yard. My yard simplified, or disappeared, I like to think of it that way. 16 times 3 gave me 48 feet. Right there. Now the next one had 2 tricks in it, but I wanted to see if you guys could do this. I'm converting 3 feet into centimeters. Okay, centimeters is my new unit, so it's got to go in the numerator. Now you have to use your reference sheet here. 2.54 centimeters are in 1 inch. That's the only thing we're given. But that doesn't help me because I'm talking about feet. So I have to throw a second conversion on. I know there's a relationship between inches and feet. Okay? There are 12 inches in 1 foot. And how did I know to put inches in the numerator on this conversion? Because I need here the inches to simplify. Here, the feet simplify, and I'm left with centimeters. So I multiplied 3 times 2.54 times 12 to get 91.44 centimeters. So try the next one. I'll give you this hint. There's 1.609 kilometers. 1.609 kilometers in 1 mile. And 1 mile equals 5,280 feet. So have at it, and we'll come back. Okay, how did you do? Here, 6,000 feet. I set up my 2 conversions. When I went to do the math on this one, or the arithmetic, I should say, 6,000 times 1.609, I give my answer, and then I divide by 5,280, and I get 1.828 kilometers. So on to our last slide. You make a banner 6 feet to hang behind the desk at the animal shelter. Your friend makes the banner 6 yards long to hang on the outside of the building. Write the ratio of the length of your banner to the length of your friend's banner as a fraction in simplest form. So we've got a lot going on here. We have 6 feet. We have 6 yards. We want to write it as a fraction. As a ratio. And we want the ratio written as a fraction, and we want it in simplest form. Okay? So we've got to do some converting because we're not, 6 feet and 6 yards are 2 different numbers, 2 different measurements. So we have to make them either all feet or all yards. The next question, example 11, has you looking at a kitten weighs 12 ounces and a puppy weighs 3 pounds. Write the ratio of the kitten's weight to the puppy's weight as a fraction in simplest form. So I'm going to let you work on both of these. You may work with your partner for now. And this is a different case because usually you're going to be working on these alone at home. But because we're doing this in class, I'm going to let you work on it with your partner today. Okay. So I'm going to do this one out with you. There's 2 ways we can do it. Like we said, the first thing we need to do is convert. So I am going to convert 6 feet into yards right now. So I have 6 feet, and I want to convert it into yards, and I know there are 1 yard for every 3 feet. So right away, my feet simplify. 6 times 1 is 6, divided by 3 is 2. So now, this is 2 yards. So now I can go up to here and rewrite this as 2 yards. So if I want to write it, I can write it as 2 yards to 6 yards. 2 yards to 6 yards. Both those numbers are divisible by 2. So if I divide 2 divided by 2, that gives me 1. And 6 divided by 2 gives me 3. So I have the ratio 1 to 3. Your friend's banner is 3 times as long as yours. The other way, I could have converted my friend's 6 yards into feet. So I could have taken the 6 yards and converted it into feet. And I know there's 3 feet for every yard. Okay, my yards cancel. 6 times 3 is 18, so we have 18 feet. Let's erase this up here. And let's change this guy to 18 feet. So when I write it from the length of my banner to my friend's banner, my banner is 6 feet. His banner is 18 feet. And when I reduce that, 6 goes into 6 once, or 6 divided by 6 is 1. 18 divided by 6 is 3. Look, I end up with the same answer because I did my conversions properly. So try the one with the puppy. Again, it can be done in 2 ways. And the final answer on this one is 1 to 4. And we are done. And if you have questions on that one, I will gladly go over that one right now with you. Okay, so we have completed our first lesson. Again, this was 2 days worth of lessons because we are going to go over this together as a class. I hope you enjoyed watching this video, and I will see you tomorrow.